All right, calculating theoretical probabilities. We're going to start out with geometrical probabilities. Calculate the area of the different regions and use areas to set up the probabilities. So what we have to do here is we have to find the area of, like for example, the shaded region versus the total area, or the non-shaded region versus the total area, depending on what it asks. Okay. So what is the probability that a point selected at random is in the shaded region? And then it says the non-shaded region. So we'll tackle these one at a time. This is a 10 by 10 square here, which is the total area. All right, so the total area, as long as I'm thinking about that, I know I'm going to need it, is 10 by 10, which is 100. Okay, that's pretty easy. The shaded area is actually made up of 1, 2, 3, 4 triangles, and each one of these triangles is has a height of 5 and a base of 5, and the area of the triangle is base times height divided by 2. So the area of the shaded region is actually going to be 4 times 5 times 5, base times height, divided by 2. So that's going to be 25 over 2, and I can cancel the 4 and the 2 there. Look at that. See, the 4 and the 2 can cancel, and you get 2 times 25, which is 50. Okay? So the probability that you select a point from the shaded area is, so the probability shaded, okay, and this is the notation for probability, P with a parenthesis, okay, shaded is going to equal the area that is shaded over the total area, which is 50 over 100, or 1/2 if you like. That's a fairly easy one to reduce. You're not going to screw that up, I don't think, right? And then the probability of the non-shaded region, well, listen, the probability of the non-shaded region, right, the probability of the non-shaded region, non-shaded, is going to equal 1 minus the probability of the shaded region. Okay? So that's pretty easy. Once you have 1, you can just use it to find the other. 1 minus 1/2 is 1/2. Okay. Another way to do that would be to find the area of the non-shaded region and then put that over the total area. All right, number 2. This one looks like a geometry class question, right? Given AB is a diameter of circle O. Angle ACB is a right angle, so this is a right angle right here. And they tell me that AC is congruent to CB. AC is congruent to CB. All right. And they also tell me that the measurement of segment AB is radical 2. So this is radical 2. Now, if you remember, right, the 1, 1 radical 2, right? So I know that CB is 1 and AC is 1 also, all right, from my special right triangles. All right, so what do I know? Probably a dart thrown at the circle will land in the shaded region. So I actually wanted to find the area of the shaded region. In order to do that, I'm going to actually take the total area and subtract the unshaded, right? So the area of the shaded region, I'll abbreviate that, right, is equal to the total area minus the unshaded, or the non-shaded area, right? We'll just do the USH, unshaded, okay? All right. And I'm doing it that way because the unshaded area is just a nice triangle, right? So my total area, right, my total area here is going to be pi r squared, right, because it's a circle, right? And what is the radius of this circle here? That's actually radical 2 over 2, because it's half the diameter squared. So that's going to give me, well, radical 2 times radical 2 is 2, over 2 times 2, which is 4, right, which is pi over 2. So my total area is pi over 2, all right? I'll also want to know my unshaded area, so that I'm going to do over here, all right? My area of my unshaded is that triangle. It's a 1 by 1 over 2, so it's 1/2. So the area of the shaded is going to be equal to pi over 2 minus 1 over 2. Now, well, that's got a common denominator, so it's pretty easy to do that. Pi minus 1 over 2. Now, to find the probability from the shaded, the probability of the shaded area is, oops, All right, that's the wrong location. Probability that it's from the shaded area, there we go, is going to equal the area of the shaded, which was pi minus 1 over 2, all over the total area, pi over 2, okay? So I can easily take this complex fraction here and multiply the top and bottom both by 2, and I get it equals pi minus 1 over pi. Now, if I was just trying to find that area, I could leave it like that and have a very nice exact answer. But you'll notice in the next part of this question, it says 3 darts are thrown at this circle. What is probably all 3 will land in the white region. Well, what that's going to be is going to be a binomial probability, NR/PQ. Either it lands in the shaded region, or it lands in the white region, or in the shaded region. Okay? And if I'm doing a binomial probability, I don't want to be raising like pi minus 1 over pi to the 3rd power kind of thing. So what I'm going to do is I'm going to find this as a decimal, pi minus 1 over pi. All right? And that is going to be pi minus 1, enter, minus pi, enter. Oh, I subtracted pi. I should have divided pi. Sorry about that. All right, pi minus 1, enter, divided by pi. There we go. That looks a little better. 0.6817. All right, and I'm going to keep quite a few decimals for this because 6817. So the probability of the shaded is 0.6817. All right. I'm going to use that down here to answer this question. All right. See, all 3 land in the white region. So I'm throwing 3 darts, so it's 3 tries. And I want all 3 of them to land in the white region. That means P needs to be probability that it comes from the white region. The probability that it doesn't is 0.6817. All right? In order to find the probability that it does, I do 1 minus 0.6817. I get 0.3183. There we go. Now, these are decimals, okay? And that's fine. All right, I'm just going to do 3C3, right? I've got 0.3183 raised to the 3rd and 0.6817 raised to the 0. 3C3 is 1, 0.6817 to the 0 is 1. That leaves just to evaluate 0.3183 to the 3rd power, which is conveniently already in my calculator. So answer raised to the 3rd power gives me 0.0322. The only thing I have to do is make sure I'm answering it if it asks me to round it to a certain place or whatever. But it doesn't. What about exactly 2 darts in the white region? Not exactly 2 darts is going to be, right? I'm doing 3 tries. I want exactly 2. Probability that I get that there is 0.3183. Probability I don't is 0.6817. Okay? So that's going to be 3C2, 0.3183. I want that twice. I want 2 in the white region, and the probability it lands in the shaded region is 0.6817, and I want that to happen 1 time. Okay? And the reason for this 3C2, folks, is to make sure I'm counting all the ways that it's possible. Maybe like the first 2 land in the white, and then the 3rd is in the shaded, or maybe the first is shaded and the second 2 are white. And you take those and you find those numbers of ways and multiply it by the probability, and it will give you the exact probability for exactly 2 darts. All right, so 3C2 is 3, 0.3183 raised to the 2nd is that, and 0.6817. I can just do times 0.6817. And then times 3C2, which is equal to 3. And I get 0.2072. And there we go. There's my answer for that. And this one was 0.0322. All right, now it says at least 2 darts in the white region. Well, that's going to be 2 darts or 3 darts. So, and that when I have or, you add. So 0.2072 plus 0.0322. All right, you add those two together. All right, 0.2072 plus 0.0322, and I get 0.2394. 0.2394. There we go. Not too bad. All right, next, moving on. All right, so here we go. We've got two triangles here. We got a smaller one shaded and a larger one not. And this is actually a trig kind of question. They tell me what the measure of angle bad, that's this right here, is 32 degrees. And they tell me that AB is 10. And they also tell me that AC, this whole thing here, is 15, and this is 11. Okay. So, points like random, what is probability? It is in the shaded region. So probability of shaded region, coming from the shaded region, is going to equal the shaded area over the total area. All right, now when I'm looking at this, that shaded area, look, I've got a side angle side. I can use that formula for area of a triangle, K equals 1/2 AB sine C. Right, K equals 1/2 AB sine C. Okay, and in this case, A is 10 and B is 11. So I'm going to have 1/2 10 times 11 times the sine of the included angle, which is 32 degrees. All right, and that's the area of the shaded over the total area. Well, okay, that's going to be triangle BAC. That's going to be 1/2. In that case, the first side is 10, the second side is 15, and the included angle is still sine 32. And the cool thing about this, before you start simplifying, these are all factors, right? So I can cancel common factors. The halves can go, the 10s can go, the sine 32s can go, and I actually wind up with 11/15. So really not a whole lot of computation for that one. When we're talking about circle spinners here, okay, these are spinners shaped like circles, and they have like unequal sections, like unequal pi sections, right? When you look at this section right in here, right? Okay, this is much smaller than the other half of the circle, or the ROS area, right? The measure of angle SOP is 30 degrees. Okay, so we're talking about this is 30 degrees right here. Okay. The key to this is to use the central angle over 360 if it gives it to you in degrees. Or let's say it gives it to you in radians, like, I don't know, it says it's like pi over 3 or something like that. Then you would put it over 2 pi, right? You're going to divide the circle into, or you could divide the circle into a bunch of equal size sectors. Right? So that's kind of the elementary way to do it. All right, so measure angle SOP is 30 degrees. What is probably a spinner will stop in ROS. ROS. So I need to know what ROS is. And these are supplementary angles, so that's 150 degrees right there. Okay? So the probability of stopping ROS is really pretty simple. It's going to be 150, right? There's 150 degrees where I could be successful out of a total of 360 degrees. All right, so it's 150 over 360. And you could kind of leave your answer right like that, or you could, let's see, I could divide 30 out of each of those, right? I think, yeah, you get 5, and down here you get 5/12. So the probability that it lands in ROS is 5/12. Okay. And this one here, probability of a 3, you have to kind of figure out how much you've divided this into, right? Well, okay, here's 90 degrees, here's 90 degrees. And these ones are equally divided, so each one of these this is like 45 degrees here, okay? So the probability of a 3 is 45 over 360, all right, which is equivalent to, when you reduce that, I think 45 even goes into 360, right? 45 even goes into 360. It's like 8 times, right? 1/8. Right? Or it's 1/8 of a pi. Probability I get an even number. Okay, well, look, right? That's even. 1, 2, 3, 4, 4/8. Okay, which is a half. Okay. Okay. So from there, we're going to use this now. I want you to do the binomial probability for that using these numbers, right? Probably exactly 3 even numbers. Oh, okay. I've got path for getting 1, so you go from there. Okay? Good luck. Thanks. Bye.